What we will now do is we'll go through each of them with examples so that one can very clearly understand what is patentable and what is not patentable. Now let's take the example of mathematical method. Now let's say you come up with a certain mathematical model. Now that mathematical model, let's say, is a new mathematical model that can calculate the shortest path between 2 points in a network of nodes. So let's say there is a network of nodes, and then every time the model gets an input saying that, okay, there are two nodes in this whole network and we need to find the shortest path between those two nodes. Now let's say your invention or the crux of your invention kind of lies in that particular mathematical model itself. Now, this mathematical model that we are looking at can be applied in multiple fields, right? So which means to say that this mathematical model is actually not tied to any field of application, so to say. So if we were to try and protect this mathematical model itself, now irrespective of how innovative this particular mathematical model could be, you will not get a patent granted, because mathematical models as standalone mathematical models or mathematical methods or mathematical formulas cannot be patented. On the other hand, if the mathematical model is actually implemented in a particular application, then that becomes patentable. For example, let's say we integrate this mathematical model into a dynamic routing system for autonomous vehicles, right? Now let's say, let's imagine a scenario wherein there are multiple autonomous vehicles, and these autonomous vehicles can move from one place to another, right? Now let's suppose we have built in a backend system which can actually implement this mathematical model, and given the input of two places, the starting point and the destination, this mathematical model can be used to actually figure out what is the ideal route what is the ideal route that this vehicle needs to be taken, this vehicle needs to take to reach from point 1 to point 2, and this system enables this autonomous vehicle to actually do that navigation. Then this mathematical model, in combination with this particular application, this particular very specific field of application, all of a sudden now becomes patentable, right? So the key learning here is that even when the innovativeness lies in the mathematical model itself, unless that mathematical model is tied to an application and we end up getting what is called as a technical effect or a technical result eventually, it does not become patentable. So once you implement this innovative mathematical model into a specific application, then it becomes patentable. Now let's take another example of mathematical models, right? Now, prime number factorization is another mathematical model that has a wide variety of applications. Typically in a prime number factorization, you find prime numbers that multiply together to give the original number, right? So, and there are multiple mathematical models around how do you end up doing prime number factorization in a more efficient way, more effective way, so on and so forth. Now, irrespective of how innovative your mathematical model could be, how efficient your mathematical model could be in terms of prime number factorization, the mathematical model alone cannot be patented. But now let's say you tie this up or integrate this mathematical model of prime number factorization into public key infrastructure, and then package your patent application as something that is crucial, let's say in digital certificate and secure web transactions, so that this factorization is used in public key infrastructures, and you have implemented that into a specific field of technology, then it all of a sudden becomes patentable. So these are two distinct examples wherein the innovation itself could lie in the mathematical model, wherein the mathematical model by itself cannot be patented, but the moment you integrate that model into a specific field of technology, it becomes patentable. So I have a question here which says, what is a mathematical method? So, like I said, a mathematical method could be a sequence of mathematical steps, or it could be a mathematical model, or it could be a mathematical formula as well, right? So any of these things could fall under the broad umbrella of mathematical methods. So like I said, pure mathematical methods standalone cannot be patented, but the moment you integrate that method into a specific field of application, a technical field of application, it becomes patentable. So when you are dealing with your own patent applications, when you are looking at applying for a patent, if you have a mathematical method that is core to your technology, then it becomes extremely important to actually integrate that into some field of technology while applying for a patent. Now, that field of technology could be a single field of technology, or when you're getting this patent document prepared, one could look at how do you make it more generalized so that it might apply to multiple fields of technology, at the same time not make it too abstract that we are trying to protect the mathematical method alone.